Assalamu alaikum. So today we are going to solve Chemistry 5070 paper 2 theory of May-June 2024. This paper is of 1 hour and 45 minutes. Let's move to first question. The first question says choose from the following substances to answer the questions. The substances given are anhydrous copper 2 sulfate, calcium carbonate, carbon monoxide, chlorine, ethanoic acid, iron, methanoic acid, methanol, nickel, silicon 4 oxide, and vanadium 5 oxide. Each substance can be used once, more than once, or not at all. State which substance A is a catalyst in the contact process. So we know it is our vanadium 5 oxide. Is a reducing agent in the blast furnace. We know it is carbon monoxide. Changes from a white solid to a blue solid when water is added to it. So we know it is anhydrous copper 2 sulfate's property to basically check the presence of water in any unknown liquid. So it is anhydrous copper 2 sulfate. Kills microbes during the treatment of the domestic water supply. So we all know that chlorine is basically used for the treatment of water supply. Has the empirical formula CH2O. It would be our only two organic compounds given to us over here are ethanoic acid and the methanoic acid. So we know it is the ethanoic acid that has the empirical formula of CH2O. Moving towards the next question. The next question states that ammonium carbide Al4C3 reacts with water to form methane CH4 and ammonium hydroxide. Construct the symbol equation for this reaction. So as only the symbol equation is required, we will not be stating the states of our specific elements present in the reaction. We will only be giving the balanced equation. So for this equation, the reactants are Al4C3, which is reacting with water, which will be plus H2O. It's giving us ammonium hydroxide and methane. So ammonium hydroxide will be AlOH whole 3 plus CH4. Now let's balance this equation. We know as ammonium are 4 over here, so let's balance ammonium first of all. Carbon are 3, so let's balance the carbon. Now let's start balancing hydrogen and oxygen. So we can see they are 4 into 3 12, 4 into 3 12 hydrogen, 12 plus 12 24 hydrogen in our product side. So let's balance it. We know if we will multiply hydrogen with 12 over here, we can have 24 hydrogen on the reactant side as well. 4 into 3 12 oxygen are present over here, 12 oxygen are present in the reactant side as well. So the equation is balanced. Methane is a saturated hydrocarbon. Why methane? Explain why methane is a hydrocarbon. So we know that each hydrocarbon is basically any compound that consists of carbon and hydrogen only. So methane is a hydrocarbon because it contains only carbon and hydrogen. Explain why methane is saturated. We know all the saturated compounds are the ones which have only single bonds between them. So that is because it contains single bonds only. Methane reacts with chlorine in the presence of ultraviolet light. I said the formula of two products for this reaction. So we know as this kind of reaction, every hydrogen in the methane can be substituted by the chlorine. So we know that let's generate the two products. Let's say it is CH3Cl and HCl. Draw dot and Gauss diagram to show the electronic configuration in a molecule of methane. So that's pretty simple. We just have to show only the outer shell electrons. So let's construct the diagram over here. This is our carbon we would be naming the element in the middle as it is CH4. So let's draw 4 hydrogen over here. 1, 2, so that will be our 4 hydrogen bonded to our carbon. Let's make the carbon electrons as dot and hydrogen electrons as cross. So that will be our dot and cross diagram for the methane molecule of methane. Moving towards the next part, it is saying that the equation for the complete combustion of methane is shown. CH4 reacting with oxygen produces carbon dioxide and water. This reaction is exothermic. Explain using the ideas about bond breaking and bond making why this reaction is exothermic. So we know that in exothermic reactions, the bond making reactions, energy is absorbed to break the bonds and energy is released in making bonds. As more energy is released than absorbed, we can see over here more energy is released than it is absorbed, as the reaction is exothermic. So we will say that bond breaking is endothermic and bond making is exothermic. So as more energy is released than absorbed, so the reaction will be exothermic. Moving towards the next part states complete the reaction pathway diagram in figure 2.1 for the complete combustion of methane. Label the reactants, products, enthalpy change of the reaction delta H and activation energy. So the reactants, as the reaction is exothermic, reactants energy will be higher than the products. So over here will be our reactants. Our reactants were CH2 and oxygen. So it will be CH4 plus 2O2, and our products will be at a lower energy level, which will be carbon dioxide plus 2H2O. Now we have labeled the reactants, we have labeled the products. Now let's label the enthalpy change of the reaction. So the enthalpy change of the reaction will be from here so let's extend a little bit the line of our reactants and products to show the enthalpy change. So this particular part will be our enthalpy change. This will be our delta H, and we can draw a dotted line over here and a dotted line exceeding this thing. Now we have done our enthalpy change. Now let's show the activation energy. Activation energy will be like this. This will be our activation energy. And we will label it EA. Got it? So we have done all of the parts. Moving towards the next question. The next question states that aqueous hydrogen peroxide decomposes when heated to form oxygen. H2O2, aqueous hydrogen peroxide decomposes when heated to form oxygen. So it is forming oxygen and water. A 35.0 centimeter cube sample of 0.266 mole per decimeter cube H2O is completely decomposed. Calculate the volume of oxygen formed, measured at room temperature and pressure. Give your answer to two significant figures. So we know, first of all, let's calculate the amount of hydrogen peroxide from the given volume and the concentration of hydrogen peroxide. So the amount or the moles of H2O2 will be equal to 0.035, or we can simply write as it is given in centimeter cube, so we will convert it into decimeter cube, which will be 35.0 divided by 1000 multiplied by 0.266, the concentration, which will be equal to 0.00931 moles. As we have got the amount of hydrogen peroxide, we can see from the equation over here that our 2 moles of hydrogen peroxide are giving 1 mole of oxygen. So amount of oxygen can be calculated. Amount of oxygen will be equal to the amount of hydrogen peroxide, which is 0.00931, divided by 2, which will be equal to 0.00465 mole. Now to calculate we have got the amount of oxygen, that is the moles of oxygen, so we can easily calculate the volume of oxygen. Volume of oxygen will be equal to the amount of oxygen, which is 0.00465 multiplied by 24 decimeter cube. As we know, in each 1 mole of gas at room temperature and pressure consists of the volume of 24 decimeter cube. So the volume of oxygen will be equal to 0.11 decimeter cube. Moving towards the next part, describe and explain the effect of decreasing the temperature on the rate of this reaction. So we can see that the reaction is a forward reaction. So if we will be decreasing the temperature of this reaction, how they are asking how it will affect on the rate of reaction. So we know that rate of reaction decreases by decreasing or on decreasing the temperature as particles will move much slower due to decrease in their kinetic energy and will have less successful collisions. Describe and explain the effect of increasing the concentration of hydrogen peroxide on the rate of this reaction. So we know hydrogen peroxide is on the reactant side of our reaction. So increasing its concentration will increase the rate of reaction, or will increase the reaction will become faster. So rate of reaction increases on increasing the concentration of H2O2 as there will be more particles. Increasing concentration means you are increasing the number of particles per unit volume. Will be more particles per unit volume, so more collisions per second, or we can say that there will be a greater collision frequency. The part D is saying a sample of aqueous hydrogen peroxide has a pH of 5.5. State which ion is responsible for this pH value. So we know as the pH is acidic, so it will be H positive ion. Part D, part 2 says a pH meter is used to measure the pH of an aqueous solution. Describe one other way to measure the pH of an aqueous solution. So we can say that we can use the universal indicator paper and match the color with pH color chart. Clear? Moving to our next question. The next question states that calcium bromide CaBr2 is an ionic solid composed of a lattice of calcium ions and bromide ions. Explain why calcium bromide has a high melting point. So as they have stated that it is an ionic solid, so basically ionic solids have strong intermolecular forces of attraction. So calcium bromide has strong forces of attraction between the positive and negative ions. So it is difficult to overcome these strong forces of attraction. That is why it is a high melting point. Describe how calcium atoms and bromine molecules react to form calcium ions and bromide ions. Use ideas about electron transfer. So we know that calcium is a metal and bromine is a non-metal. So calcium atom loses 2 electrons and becomes a calcium 2 plus ion. Bromine molecule, as you know, bromine is in gaseous state under room temperature and pressure. Bromine molecule gains 2 electrons and becomes or we can say forms a Br minus ion. Two Br minus ions. Predict the products at each electrode during the electrolysis of dilute aqueous calcium bromide. So as it is dilute aqueous calcium bromide, so we know from our reactivity series that calcium and bromine both are less reactive than hydrogen and hydroxide ions. So obviously at anode, oxygen and water will be produced. H2O, or we can say water. And at our cathode, hydrogen ion will go and will produce hydrogen gas. Part D1 is saying ozone is an oxidizing agent. Describe the color change when ozone gas is bubbled through aqueous potassium iodide. So the color change will be colorless to brown. Zinc is a reducing agent. Describe the color change when excess zinc is added to acidified potassium manganate. We know as acidified potassium manganate is reduced, it will go from purple to colorless. Part E is saying that the ionic equation for the reaction between aqueous calcium bromide and aqueous chlorine is shown. Explain in terms of electrons why this reaction involves both oxidation and reduction. So we can see in this reaction that bromine or the bromide ions are oxidized since they lose their electrons, whereas the chlorine molecule, it is reduced since it is gaining the electrons as shown by the negative sign. So that is what we will write, that bromide ion is, or we can yes, bromide ion is oxidized since it loses electrons and the chlorine molecule is reduced by gaining electrons and produces 2Cl minus ions. Now question number 5 is stating, when a sample of zinc carbonate is heated in a closed system, an equilibrium mixture is formed. The zinc carbonate in the solid state is reacting in a reversible reaction with producing zinc oxide in solid state and carbon dioxide in the gaseous state. The forward reaction is endothermic. The temperature of the closed system is decreased and the pressure is kept constant. Predict how the position of equilibrium for this reaction is affected. Explain your answer. So we know that our endothermic reaction, basically in the endothermic reaction, energy is absorbed to break the bonds. So it means that our backward reaction will be exothermic reaction, in which energy will be released on making the bonds. So decreasing the temperature will favor the left side of our equilibrium, or the exothermic side of our reaction, that is the left side. So position of equilibrium moves to the left to release thermal energy. Second part saying the pressure of the closed system is increased and the temperature is kept constant. Predict how the position of the equilibrium of this reaction is affected. Explain your answer. As we know that where there are lesser molecules of gas, the increase in the pressure will favor the side of the equilibrium of the reaction where there are fewer moles of gas. So we can see there are fewer moles of gas on the left hand side, so the position of equilibrium will move towards the left. Again, position of equilibrium moves to the left as fewer moles of gas are present on the left hand side. or we can say are present on the reactant side. Moving to our next part, it is saying, part C is saying that calculate the maximum mass of zinc oxide that can be made from 4.23 gram of zinc carbonate. So we have to calculate the maximum mass of zinc oxide. So first of all, let's calculate the MR of our zinc carbonate. As the mass is given, so we will take out the number of moles. For number of moles, we must know the MR of ZnCO3, which will be equal to zinc is 65 plus 12 plus 16 into 3, which will be equal to 125. The MR of zinc oxide will be equal to 65 plus 16, which will be equal to 81. Now let's calculate the amount of zinc carbonate. The amount of zinc carbonate will be equal to the mass in grams, which is 4.23 grams, divided by MR of the molecule, which is 125, and it will be equal to 0.03384 mole. Now, as we know from the equation that 1 mole of zinc carbonate gives 1 mole of zinc oxide, so it means that the amount of zinc oxide will be the same as the amount of zinc carbonate, that is 0.03384 mole. Now, to calculate the mass of zinc oxide, you will just rearrange the formula for the number of moles, which will be equal to mass equals to number of moles or amount of substance divided by MR of the molecule, which will be equal to 0.03384. Now, in order to find the mass of zinc oxide, we will just rearrange the formula of amount of substance, which is basically mass of zinc oxide will be equal to amount of zinc oxide multiplied by MR of zinc oxide. We have already calculated the amount, it is 0.03384, and we also calculated the MR of zinc oxide, which is 81, so it will be equal to 2.74104 grams. 2.74104 grams. It is already given. That would be all. Part D is saying that zinc oxide reacts with both aqueous sodium hydroxide and dilute hydrochloric acid, but carbon dioxide only reacts with aqueous sodium hydroxide. Explain why. So we know that zinc oxide is amphoteric substance and the carbon dioxide is acidic, because zinc oxide is amphoteric while carbon dioxide is acidic. Part E is saying that solid zinc carbonate reacts with dilute nitric acid to give a colorless solution and bubbles of gas. Construct the symbol equation for this reaction. Include state symbols. Now you also have to include the state symbols. So let's go into it. Solid zinc carbonate means that NCO3, and it is a solid. It's reacting with dilute nitric acid. Dilute nitric acid means that it is HNO3 in aqueous state. and is producing colorless solution. To give a colorless solution, bubbles of a gas. So the colorless solution will be zinc nitrate 3(2), which is again aqueous, as this is a colorless solution, and bubbles of gas. The gas will be carbon dioxide as well as water will also be produced and it will be in liquid state. Now let's see if the equation is balanced. So there 2ZNO3, so let's put 2 over here, and this makes our equation balanced. Yes. Moving towards the next question. The next question states that methane, nitrogen monoxide, and sulfur dioxide are air pollutants. Describe one adverse effect of higher levels of methane in air. So higher levels of methane will be causing an increased level of global warming. So you can say increased global warming. The combustion of fossil fuels that contain sulfur produces sulfur dioxide. Describe 2 strategies to reduce the emission of sulfur dioxide from the combustion of fossil fuels. So we can say that we can react the sulfur dioxide with calcium dioxide to reduce the emission of sulfur dioxide. We could use low sulfur fuels like low sulfur petrol, or we can use less fossil fuels, or basically we can use renewable energy resources in which there is no sulfur dioxide emission. So we can use low sulfur fuels, and we can also use renewable energy sources such as solar. Okay, you also have to name the renewable energy source. Nitrogen monoxide is, and the expert is saying that nitrogen monoxide is linked to acid rain. This pollutant is present in the gases made in car engines. Describe how nitrogen monoxide is removed from these gases. Include a word equation in your answer. So nitrogen monoxide is removed from a catalytic converter. So it can be removed using a catalytic converter. And what happens in a catalytic converter? The 2 toxic gases, which are nitrogen monoxide and our carbon monoxide, are combined together in this catalytic converter, and they give off carbon dioxide plus nitrogen. Part 2 is saying state 2 other adverse effects of oxides of nitrogen pollutants in the air. So we know that oxides of nitrogen can cause respiratory problems, as well as they create photochemical smoke. That would be it. Moving towards question number 7, it says that oxygen is a gas at room temperature, sulfur is a solid at room temperature. A sample of oxygen has a volume of 540 centimeter cube at room temperature and pressure. The temperature of the sample is increased, but the pressure is unchanged. Describe and explain in terms of kinetic particle theory what happens to the volume of the sample? So when the temperature is increased, we know that volume increases and the particles, they spread out, or the distance between the particles increases. So as the temperature increases, the volume of gas in the volume of the sample increases as the particles gain more kinetic energy and spread out or move away from each other. Part B says that sulfur is a gas above 445 degrees centigrade. Describe the changes in particle separation, arrangement, and motion when a sample of sulfur gas is cooled down to room temperature. Now, obviously, when the temperature will be lowered, the separation of the particles will be lowered. So they will move closer together. Arrangement, obviously, as the gas particles were in random movement, now they will be in more ordered movement, ordered arrangement. So it will be random to an ordered arrangement. The motion of particles, obviously, first of all, they were in the gaseous state, they were moving away from each other, they were free to move, but as they are now close together, so they will vibrate from one place to another. Moving from one place to another to vibrating. Part C asks, describe diffusion in terms of kinetic particle theory. So we know it is the movement of particles, or basically the net movement of particles from high concentration to low concentration. Part D says the symbol of a sulfide ion is shown. Complete table 7.1 about the sulfide ions. So we know the protons will be 16, the neutrons will be 33 minus 16, which will be 17, and the electron, as we can see, it has a 2 negative ion, so it means that it has gained 2 electrons. So it will be 2 more than the number of protons, which will be 18. Question number 8 says, figure 8.1 is a flow diagram showing information about some organic chemical reactions. Butane 1-ol reaction with KMnO4 H2SO4 aqueous produces C compound. Ethanoic acid catalyst produces ester P. Draw the displayed formula of compound A. So compound A is basically butane 1-ol. Butane 1-ol means that we would be having the long chain, the 4 carbon long chain of our compound, and it will be hydrogens, and let's say that over here it is oxygen and hydrogen, so it will be butane 1-ol. State the name of ester B. So ester B, you can see that butane 1-ol is reacting with ethanoic acid and creating an ester B. So butane 1-ol, when it will be reacting with ethanoic acid, it will produce the ester, which will be butyl ethanoate. State the name of compound C. Compound C is produced by the reaction of butane 1-ol with KMnO4 or H2SO4. So it will be, and as we can see, it is a carboxylic acid over here and a 3-carbon chain and a 4-carbon chain with a carboxylic acid. So it is butanoic acid. Deduce the molecular formula of compound C. So the compound C's molecular formula will be C4H8O2. Part D says state the name and formula of compound D. The compound D is basically formed by the reaction of butanoic acid with NaOH. D is formed and the liquid F is formed. It is also formed by the reaction of this butanoic acid with Na2CO3 while giving off a gas and a liquid F. So the name of the formula, the name of the compound D will basically be sodium butanoate. And the formula of compound D will be CH3 CH2 CH2 COO. So that's 4-carbon, that is butanoate, and so there is our sodium butanoate. State the formula of the gas E and of liquid F. So gas E will obviously be carbon dioxide and the liquid F will be water, which would be produced due to this OH part over here. So it will be gas E is carbon dioxide and F liquid is H2O. Draw the structural formula of ester G. Ester G is produced by the reaction of butanoic acid with CH3 CH2OH. So the ester produced, the structural formula of ester produced will be CH3 CH2 CH2 COO. That would be our butanoic acid part, and now the part of our alcohol, which is CH3 CH2. So it will be flip, which will be CH2 CH3. That would be the formula, structural formula of our ester G. Moving to question number 9. Question number 9 states that polymers are made by either an addition reaction or a condensation reaction. Figure 9.1 shows the equation for the reaction used to prepare a polymer. The monomer is both an alcohol and a carboxylic acid. Name the type of linkage that bonds the repeat units to one another in this polymer. So as we know that carboxylic acid and alcohol linkage is basically forms ester linkage. Explain how the equation shows that the polymer is made by a condensation reaction. So we can see a water molecule is released. So that is the identification of condensation reaction. So we say that polymer is made together with a water molecule. Part B says a polymer contains 10.8% carbon, 7.1% fluorine, and 72.1% bromine by mass. Calculate the empirical formula of this polymer. So to calculate the empirical formula, first of all, we know the percentage by mass of carbon is given, fluorine is given, and bromine is given. For carbon it is 10.8, for fluorine it is 17.1, and for bromine it is 72.1%. Now let's calculate the number of moles or amount of each of our element. It will be 10.8 divided by the MR of carbon, which is 12. This will be 17.1 divided by the MR of fluorine, which is 19. and bromine it's 72.1 divided by the MR of bromine, which is 80. So it will give us 0.9. This will give us 0.9. This will also give us 0.90. So the ratio, the simplest ratio will be, obviously as all are the same, so simplest ratio will be 1:1:1. So the empirical formula will be CFBR. All the substances will be in, all the elements will be in 1:1 ratio. Part C says some plastics are made from polymers that are hydrocarbons. There are many environmental challenges caused by plastics. Explain why there is an accumulation of plastics in the oceans. Use ideas about the properties of plastics. So we know plastics, they do not dissolve in water. Basically, they are unreactive. So we say plastics are unreactive, hence does not dissolve in water. Part 2 states that explain why the disposal of plastics causes an environmental challenge. Obviously, if they are not dissolvable in water, they won't be properly decomposed. Secondly, there will be incomplete combustion of the carbon, there will be incomplete combustion of the plastic, and as plastic is made up of hydrocarbon, so it will produce carbon monoxide, okay, and it will also produce toxic gases along with carbon dioxide. So we will say that incomplete, first thing is that incomplete combustion of plastic produces carbon monoxide. Secondly, burning or incineration of plastics produces a poisonous gas. So that would be all for our chemistry paper 2 of 2024, May-June 2024. Hope you understand it. Thank you so much. Allah Hafiz.